right, so what we're going to do, we're going to estimate the area under these curves. So you're going to have curves that are not geometric figures. So if you look at this, we're going to come up with different ways to estimate this. One way we're going to estimate is using rectangles. So rectangles an easy area to go through and find. We'll use a rectangle to estimate the area. So if you look at this is the graph of y equals x squared. We're going to go from x equals 0, x equals 2. So this is the only region that I want to estimate the area for. Okay, so that's what I'm going to go through and estimate. So there's lots of different ways to go through and situate these rectangles to estimate this area. So what I'm going to do is I'm going to divide this up. Now, depending on what the problem says, you could use lots and lots and lots of rectangles. You could use just a few rectangles. For most of the problems, I'm going to tell you use 4 rectangles. It gives you a pretty good estimate without going too crazy there. So this was 0, this was 2. If I divide this up into 4 equal intervals here, halfway between 0 and 2 is 1. Halfway between 0 and 1 is 1/2. Halfway between 1 and 2 is 1.5. So that's how I came up with those values along my x-axis here. So what we're going to do is we're going to go through and we're going to estimate using a lower sum. What a lower sum is you're going to make your rectangle, and depends on the shape of the curve where this is going to end up. You want your rectangles to fall below the curve. So if I look at this first interval, if I use this endpoint on the left, that rectangle will fall below the curve. And that's a hard one to see because this looks like a what? It has a height of 0. It doesn't even look like a rectangle. Look at this one. This next interval here. Here's my interval, my curve. If I use this endpoint, my rectangle will fall below the curve. Are you seeing it? Okay. In this next interval, if I use this left endpoint, my rectangle falls below the curve. And same with this one, using the left endpoint. So these are the 4 rectangles that I'm going to find the area of. Okay, so let's find that area. I'm going to stick it right up here. So I want the area of a rectangle. How do you find the area of a rectangle? Length times width, base times height, either one. So look at this first rectangle here. Its base is how long? 0.5. And the height of that rectangle we said was 0. For my next rectangle, the base is 0.5. The height I can find if I plug this left endpoint, this x value, into my function, and my function was y equals x squared. If I plug that into the function, I'll get the height for that. That's where your calculator comes into play. So turn your calculator on, hit your y equals. We're typing the equation in, which is x squared. Clear it out. Right, and you don't need to necessarily look at the graph. If it's helpful for you, you can look at the graph. But what you need is the table function for the calculator. So you're going to hit the second key and the graph key. And then you should be able to type numbers in there. If you can't type numbers in, just holler and then we'll be able to go through and do that. So type in 0.5. And you get an outcome of 0.25, yes? Okay, so that's the height of this rectangle right here. All right, let's go to the next one. What's this next rectangle's base? 0.5 times its height. Well, its height happens right here when x is 1. That one you may be able to do in your head. If you type in 1, you get an outcome of 1. All right, and then the last one. Are you guys able to type these into your calculator? Okay. Anybody not? Hit the second key.
Yeah, second. Do I just switch to add?
Second, yeah, S. Yep. Alrighty, and then the last rectangle here, we said its base was 0.5. Its height happens right here. When x is 1.5, we can find this y value, which would be the height. So type in 1.5, what do we get? Okay. Now, some of these problems, you're going to have lots of decimal places. You want to use all the decimal places that you see in this table. It'll usually be 4, sometimes it'll be 5. Use all of those decimal places, and then your final answer you can round to 3 decimal places. This one, the decimals end pretty early there. You only have a couple decimal places. All right, so if you look at this, I could take all of these things here. I have 0.5 in common in all of these. I could, if I want, take that 0.5 out of all those and just add these y values together, these heights together. Right, and if I do that, I add these all up, multiply by 0.5, what do we get for our lower sum? What is it? 1.75. I'm going to slide this down a little bit. I'm going to write this underneath here, this value. So we got 1.75 for this. Lower sum. Okay, and once we see how to set these rectangles up and these endpoints up, this isn't really difficult. It's kind of tedious. Okay, and it's real nice to be able to use the calculator because the calculator you'll be able to reuse the values again if you have it in that table. All right, so this one we use lower sum. We put the rectangles so they fell below the curve. We're going to do the same thing, but now we're going to situate the rectangles so they fall above the curve. So if you look at this first one, instead of using this left endpoint, if I use this right endpoint, there's my rectangle. It goes above the curve, but that could be a way that I could estimate that area. This next rectangle, if I use that right endpoint, now I'm looking at this rectangle. Right endpoint gives me all of that, and same thing. Now, what kind of number compared to this lower sum do you think you're going to get?
Bigger one.
It's going to be bigger because you have bigger rectangles. The rectangles fall outside of the curve. But the area is going to end up looking the same way. It's the same process. Right? So this was 0, this was 2, 1, 0.5. 1.5, all that's the same. Okay. If you look at this, though, the values that you're going to plug in are going to be from these right endpoints here. Okay, those give you where the rectangle and the curve intersect. That gives you the height. So tell me about all of these rectangles. What's their base? All of them have the same base. They all have a base of 0.5. So I'm going to leave that out front, and I'm just going to add the heights together and then multiply that sum by 0.5. So right here in this first rectangle, that height happens when x is 0.5. So in your calculator, plug in 0.5, what do you get? You already have it in there. You get 0.25, right? Right, so plug it into your calculator. This is what you're looking at. Right, when you plug in 0.5, you get 0.25. Right, plug in the next one. Plug in 1 into the calculator. What do you get? This height is 1, right? Plug in 1.5, that's this endpoint here. What's the height for that rectangle? 2.25. Plug 2 to get the height of this last rectangle. What do we get? 4. All right, add them up, multiply by 0.5. What do we get for our upper sum? What is it? 1.25? Yep, try it again. 3.75. And how did you know? As soon as you said it, you said, oops, that's wrong. How do you know it was wrong? Has to be bigger than the 1.75. All right, so this is nice. The part underneath there says left sum, right sum. Sometimes what will happen is some of these curves, if you look at their endpoint, in this case, the lower sum, we use the left endpoint, shush, for each one of these. For this one, we use the right endpoint to come up with the height for each of these rectangles here. So another name for this particular one, this lower sum is also the left sum. Instead of saying lower, you know, how the rectangle falls compared to the curve, they're going to say use the endpoint that's on the left. Okay. Okay, so left sum means use the left endpoint. Right sum would be use the right endpoint. Now what happens, sometimes, depending on the shape of the curve, the right sum may be the same as the upper sum. Sometimes, depending on the shape of the curve, the right sum might be the same as the lower sum. Depends on the shape of the curve and the concavity for the curve there. They are the same thing for this particular one. Yeah. Not always the same. No. It depends on the shape of the curve. We'll do another one where you'll see that it ends up flip-flopping around. Depends what the curve looks like, whether it's increasing or if it's decreasing, if it's concave up or concave down. All right, so our lower sum was too small, our upper sum was too big. Any idea how to find a sum that's going to be a little more accurate? Oh, you're jumping ahead to tomorrow. You're right.
Whoa.
Yep. You could use, instead of, and really it's not exactly triangles. Let me see if I can give you a, so instead of, really it's not going to be triangles, it's going to be a triangle on the top with the rectangle on the bottom, which gives you a what? A trapezoid. Okay, so that's where the triangles come into play. Alrighty, so using a different shape can give you a better estimate. What if we stick with rectangles? How can we make it have a better estimate? Starts with an N. Midpoint mean. Yeah, you're both kind of right there. Okay, so what we're going to do is instead of just sticking strictly with the left or the right endpoint, if we stick those rectangles so that the midpoint of that interval, now I have a rectangle where I have a little bit of area above and below. Some that's not included, some that is included. Same thing with this one. These two kind of balance out, these two kind of balance out, kind of balance out. Now it's not going to give you the exact value, but it's going to come pretty close. It's going to give you a pretty good estimate. So let's use this midpoint sum. So let me get rid of this. All right. Now what will be different is this is still 0 and 2 and 1, 0.5, 1.5. But what I need is where is this midpoint happening? What happens halfway between 0 and 0.5, which is 0.25. This midpoint happens halfway between 0.5 and 1.75. This midpoint halfway between 1.25, this midpoint halfway between, which is going to be 1.75. So these are now the x values that you're going to put in for your equation. So this is my equation, y equals x squared. If you go back to your calculator, okay, still have y equals x squared in there. If I type in these x values, 0.25, 0.75, 1.25, 1.75. Now it's going to give you the heights for the rectangle that falls in between there. Tell me about the base for all of these, though. What's the base for all of these rectangles?
0.5.
Still 0.5, right? We're still using a base of 0.5. So I have 0.5. Get that out of the way for my base. Now the heights. What was the height at 0.25? 0.0625? At 0.75 you get what? 5625? 1.25? 5, 6, 5? 25? Up. 625. All right, 1.75? All right, add them up, multiply by 0.5. Right. 2.625? Okay. So of the three sums that we came up with, the midpoint sum is going to be the most accurate so far. for that estimate. You're going to do all of them. It'll just depend on the problem. Okay? All right, so let's look at this. We're going to put all these together here. Let's go down to, I'm not going to do all these examples. We'll go through and set these up. All right, so let's look at this one because I know you like trig. So sine is x over 2. So the first thing you should do is what with the calculator? Graph and make sure you're in radians. If you're in degrees, you're going to get a very different graph. Oh, that's good.
Wow.
All right, make sure you're in radians. We're in radians. I'm sure there would be a clown that would put it in degrees. All right, so sine of x divided by 2. All right, I would also hit the window. If you want to look at this graph, because you're not going to be given the graphs on the worksheet that you have, you're going to have to come up with the graph. So change your window. Let's go from 0 to 2 pi. All right, your x scale, you can decide what you want to make it. It really doesn't matter. This is pi over 2, it looks like. And then my y min and my y max, -4 to 4. That's all right. You could look at that. You may even want to make that smaller, maybe -2 to 2. And then you can graph it. Looks kind of like our graph there, right?
X scale.
Okay, x scale was pi over 2. All right? So if you look at this, the directions, shh, you guys are very chatty today. It's irritating me. Just thought I'd throw that out there. And now it's on tape, because this is all being taped, I told you. Yes. All right. Evidence. All right, so we're starting at 0. We're going to 2 pi, because they told me to. They said let n equal 4. What does that mean? Number of intervals. You got it. So halfway between 0 and 2 pi is pi. Halfway between 0 and pi is pi over 2. Halfway between pi and, you got it. Okay, so they're my intervals. So I can find lower sum, upper sum. Let's look at these lower sum and upper sums because they're a little bit different for this one. The lower sum, I want the rectangles to be below the curve. So look at this first interval. Which interval, or which endpoint, left or right, do I have to use to have the rectangle be below the curve? The left. If I put my endpoint here, there's my rectangle that would be below the curve. If I put it here, there's your rectangle. See, it's going outside of the curve. Okay. How about in here? Which endpoint is going to give me a rectangle below the curve? The left again, right? So there's my rectangle. Look at this one. Which endpoint, left or right, is going to give me the rectangle below the curve?
Right.
The right this time. Right? And then this one, which endpoint, left or right?
Right.
On the right, it's going to be below. Okay, use pencil when you do these. You can draw the rectangles, and then if you have it on the wrong side, erase it and redo it. All right, so let's do lower sum. All right, what is my base going to have a width of, or my base have a width of? What's the base going to be for each one of these intervals? Pi over 2, so I'm going to leave that out front. Okay, so now I need the height. Well, this one you can probably guess what the height's going to be. When you plug in this left endpoint 0 into here, what height do you get? 0. If you're not sure, put it in the calculator. Look at it. In your calculator, type in this left endpoint. The height of this rectangle happens back here at pi over 2. What do you get when you plug in pi over 2? Right, 70711, I think it is. Right? Okay. This next interval, the endpoint that gave you the height here was what value? The 3 pi over 2. Type 3 pi over 2 in your calculator. Same thing, you got it. They have the same height. And how about this one? The endpoint that gives you that height is 2 pi, you get 0. Type them in your calculator. Add these guys together in the parentheses. Multiply by pi and divide by 2. What do we get? 2 point.
That's right. This is all why the show is 2.22.
One more decimal place. 0. 1. Okay, round your final answer to 3 decimal places. That's right. Right, let's try and do upper sum. See what happens with upper sum for this one. So now we're going to look at these intervals. We do this one. Which endpoint here is going to give me the curve, the rectangle outside? It's going to be this right endpoint. So now my rectangle falls outside of the curve. How about this one? Which endpoint?
Right.
The right? So now my rectangle's above the curve. How about this one? The left this time, okay? So it's the same rectangle really for both of those. And then this one, which endpoint, left or right? Left. Right, so let's find that upper sum. Pi over 2 is still my base. Right, now this is where the numbers get reused again. This height for this first rectangle here happens at pi over 2. You plug pi over 2 and you get that 0.70711. The height for this next rectangle happens at pi. What's the height at pi? 1. This rectangle has the height that happens at pi, which gives you 1. And then this guy, 70711. Add them up, multiply by pi over 2. What do we get? 304. Okay, so there's good to 3 decimal places. Okay, just round it to 3. All right, now look at this one. What's a little bit different is that left sum and that right sum. Okay, it's not the same. It's not one of these or the other one. It's actually kind of a combination of both of them. So there's my intervals. So if I use the left sum is using just the left endpoints. So left sum, I'm using this endpoint on the left of this interval. In this interval, I'm using this left endpoint. This interval, I'm using this left endpoint. This interval, I'm using this left endpoint. So I'm plugging in. The base is still pi over 2. This height is 0. This height is at pi over 2, which is that 0.70711. This height happens right here at pi, which is 1. This height happens right here. 3 pi over 2 gives me 0.70711. Okay, so don't use the 2 pi at all. Add them up. Multiply by pi over 2. What do we get? Okay, 3.789. What do you think the right sum is going to be? Yeah, it is. It's actually the same thing as the left sum this time. You can try it. 3.789.
Good afternoon, everyone. This is Christine with Reminder about the schedule for tomorrow, Tuesday. Tomorrow will be